In this lesson, we're going to cover some terminology associated with networks. So in some graphs, an edge will have a number next to it. That edge is called a weight. It can represent all kinds of things, but often it's used to represent a distance or the length of time taken to travel along that edge, if the edge represented, for example, a road. A graph that has weights associated with it is called a network. Sometimes vertices are called nodes when we are talking about networks. And sometimes edges are known as arcs. Sometimes an edge will have an arrow on it, indicating that it can only be travelled in one direction. If this is the case, it will be called a directed edge. Sometimes a graph with directed edges on is called a directed graph or a digraph. Arrows can be used on graphs without weights as well as in networks. This network represents the cost of linking up 7 cities. Each of the weights on the arcs tells you the cost in thousands of pounds. By trial and improvement, I'd like to try to find the answer to the 3 questions on the right-hand side. So the first one, the cheapest cost to link up cities A to G by inspection is by travelling along A, B, F, E, G, and the total cost there is 28. The second question, so the cheapest cost to link up all of the cities in a tree. So this is what is known as a minimum connector. We're going to look at this later in the course. And you'll see that this tree links each of the vertices in as cheap a way as possible. And the cost for that is 43. And finally, we'd like to find the cheapest cost of a trail that would go along every arc. So starting at A, and finishing at E. You can see that this was possible because it was a semi-Eulerian graph. So A and E were the 2 odd vertices. So therefore, the cost of travelling along every arc is actually just the total cost of all of the arcs on the network, which is 100.